Okay guys, I'm going to work through review with you. So let's go ahead and start. This picture here, right, means we're going to go down 4, correct? The number when it's by itself, it's up and down. So we're going to go down 4, and then you can draw the hill graph. So for your domain, the x values would just be from 0 to infinity. And your range would be from -4 to infinity. And there are no zeros. Number 2, if you sketch the graph, it's a parabola, and you're going to go down 7. So down here, and you still make a U. Your domain of a parabola, remember, is all real. Your range is going to start from this -7 and go up. So -7 to infinity. And your zeros, there's actually 2 zeros there, guys. You have to solve for them. So if you take t squared, let me find room, t squared minus 7 is 7 equal to 0. If you move your 7 over, t squared is 7. And then you take the square root of both sides. But remember, there's a positive and a negative value. So your square roots are positive and negative square root 7 equals x. This is a hill, but you're going to move right. So we go to 6, graph a hill. So your domain is going to be from 6 to infinity. And your range is going to be from 0 to infinity. Your zeros, you just need to look at that. Where is that at? That's at 6, 0. 6, 0. Okay? This problem actually needs to move right 3. That, if you will remember, is the rational function graph. That's that weird graph. So you're going to go right 3, and remember, we have a new little axis here so that we can make our strange graph. The domain, okay, is all real, except what x value are we not going to hit? X is not 0, remember? Same for range. The range is all real, and y is not 0. And because we didn't move it up and down, there are no zeros. So we're going to put none for there. Here, we're going to go right 3, right? Remember, when it's with x, you do the opposite, and then up 2. So in our little picture, right 3, up 2 starts me here. That's the hill. So for your domain, that's your x values. If you look at your x values, you're starting at 3. So 3 to infinity. Your range, you're starting at 2, because we moved it up 2. 2 to infinity. And for zeros, there are none. It does not hit this x-axis at all, so there are no zeros. This is the V graph, remember? And I'm with x, so you do the opposite, left 5. With x, remember, when you're under the radical or in the brackets, that with it you do the opposite. So that means you're going to go left 5, and then a V. My domain, all real numbers. My range starts at 0 and goes up. And my zeros, there's actually just one right here, -5, 0. Determine if it's a function. Yes, it passes the vertical line test. That would be a yes. Give the domain and range. The domain, if you guys struggle with domain, you could use note cards even. Look, domain is x. You're going to slide these note cards on the x-axis, which there they are. I'm going to go from this mark to this mark, which is -6 to 7. For the range, you can go this way. Slide it up and down this way with your note card. Okay, if you slide it up and down this way, you're here to here, which is this mark to this mark. That's the window, which gives us -7 to 2. Okay, the next one asks you to find each of the following. This is a plus, so you're going to add the 2 functions. So x squared minus 1 plus x plus 1. Put like terms together, so x squared plus x, and the 1's cancel. So there's your answer. The minus is the one that we did as a warm-up. It's the tricky one. So you're going to take f, which is x squared minus 1, and you're going to subtract all of g, which is x plus 1. Remember, you have to distribute that negative. So x squared minus 1 minus x minus 1, which gives you x squared minus x. You can put these together to give you your minus 2. This means to multiply. So you're going to take x squared minus 1 and multiply it times x plus 1. You have to FOIL it, which gives you x cubed plus x squared. And then you go the other way. You've got to take negative 1 times both, which gives you negative x minus 1. And you combine like terms, but nothing can go together. A 3, a 2, an x, and a 1, so you're just done. Number 11 has a fraction, which means it's going to have a restriction, remember? So I'm going to take x squared minus 1 over x plus 1. This can be factored. Now, it's been a while, but it can be factored into x plus 1 times x minus 1, remember? And then x plus 1 is on the bottom. These cancel, and you're just left with x minus 1 in the numerator. So that's your answer. But now you have a restriction. Remember, the denominator, x plus 1, cannot equal 0. So if you move your 1 over, x cannot equal negative 1. That's your restriction. Number 12, you find g of negative 2 first. You take negative 2, you come over here, and you plug negative 2 in for x. So g of negative 2 would be negative 2 plus 1. So g of negative 2 actually gives us negative 1. Then you take negative 1 and you plug it into f because you're finished with that part. So go over to f. Be careful. F of negative 1, don't forget to write that part. That's important. Negative 1 squared minus 1. Negative 1 squared is 1. 1 minus 1 is 0. So the answer is 0. Notice when I plug a number in, you write your answer like that. This little circle, remember, you take g of x and plug it into f. It's the same thing as this. So if I take g, and I'm going to plug it in where I had x, so the x goes away, which means you want x plus 1 squared, right? Remember the squared? Minus 1. You have to be careful because x plus 1 squared, you actually have to FOIL that out. That's x plus 1 times x plus 1, which is x squared plus x plus x plus 1. When you combine like terms, you get x squared plus 2x plus 1, and don't forget to drop down this minus 1, which cancels. So there's your answer. Let's go to the back. Okay, I think for time reasons, I'm going to do this problem, and then I'm going to skip these two. This means find h of 4. So go to h and plug in a 4 for here. 2 times 4 plus 4 would be 12. So h of 4 gave us 12. Now you take 12 and you plug it into g. So I want g of 12, which would be 12 plus 5, which gives me 17, right? So g of 12 gave us 17. Then you take that answer, the 17, you plug it into the last one, f. So f of 17 is 3 times 17 minus 3. When you do the math, you get 48. So f of 17 is 48. Okay, the last two parts are down here. Remember, this is kind of like saying the opposite of your y's, which flips x. Agree? And this says absolute value, so you want everything to be above x. And this says the opposite of x's, which means you're going to flip over the y. You're going to take the same picture. So if I'm going to flip it over the x, if I went up, I'm going to go down. So this picture went up 2, so we're going to go down 2. Right? I've done that point. Then you move to the next point. It went up 2, we're going to go down 2. And then we connect, remember? We go to the next point. I went down 3, so I'm going to go up 3. And then I connect. So plot, connect, plot, connect. So I've done this one, and this one. Now I'm left with 2 more. This one went up 2, we're going to go down 2. This is on the axis. So it stays there. This is the above x. So if it was above, like I'm just going to sketch this one for you. Okay, I was above, so I'm going to stay above. From here to here, we just trace it, remember? And then it stays above all the way here, and all of a sudden it stops. So here's the weird part. This point here now needs to be moved up. So this V kind of goes upside down. So down 3, up 3. It's going to be a new V, like this. And then this part, so I took care of this part. This part's already there, so you're just going to go up and over. Okay. The last one, 19, is flip Y. To flip Y, you flip over this axis right here. So if I'm flipping here, that's the, if I went left, you now need to go right. Start with point 1, we'll name them. Point 1, 2, start here. So if I was over here, I've got to go to the right. So if I went left 9, I now need to go right 9. So you're here. Go to point 2. I went left 2, so I'm going to go right 2, and then connect. Now go to point 3. Point 3 went right 2, so you're going to go left 2, and then you connect. Point 4 went right 6, so you're going to go left 6. And connect. And the last one, point 5, went right 7, moving this one now. So we're going to go left 7. Okay? The last 3 are the even, odd, or neither. Remember, even is they're all the same. Odd is they're all opposite. And neither can be a little bit of both. And you go in and you plug in negative x everywhere you had an x. So negative x to the 4th power minus 2 times negative x squared plus 5. Everywhere I had an x, I replaced it with negative x, right? Then you evaluate it. If it's an even, since this is a 4, it's even, this stays positive. This is an even, so it's going to be positive. Remember, because a negative x times a negative x is positive x. So this is positive. The problem is, this is a tricky one. The 2 is negative. So a negative 2 times a positive stays negative. Negative times a positive is negative. And then drop down your plus 5. Now go back and compare. Same, same, and same. So that everything's the same, so it's called even. Now for 21. Do the same thing. Plug in negative x. So you're going to have this. This is an odd exponent, so it stays negative. I've got 2 negatives here. Well, this is a negative x, so it's going to be negative. And negative make positive. Now compare. Opposite, opposite, right? This is a positive, it's now negative. This is a negative, it's now positive. So they're both opposite. When everything's opposite, it's considered odd. Last problem. Plug in negative x again. This is a 3, an odd number, so it stays negative. The value of just this part right here is positive because of the 2. A negative and a positive are going to be negative. Now compare. Opposite, same. So this one is a neither. All right, that's it. If you still have struggles with these, you might try them again. All right, good luck, and we'll see you tomorrow.